Welcome back, class. Today we're going to look at 2-1 from the book, which is Inductive Reasoning and Conjecture. Again, these are past lessons, but if you need to go back and review for the exam next week, that's what they're here for, alright? Also, anytime, final exam, midterm, whatever you need to study for, they're here for you. Or if you just want to get a refresher on what the words are we're talking about in class. Again, I'm making these videos from home, so this one's a little bit later. My wife is taking care of my son for the moment, but the dogs are still here and they could bark, so if that happens, I apologize ahead of time. So, here's our warm-up from the day that we did these notes. Just going to go through these, true, false, each one. So, plane M contains line CD. You can see plane M is the big parallelogram that is going left and right, pretty flat, from what we can tell. That is a plane, so it's going to be, but plane M contains line CD, and line CD is this guy right here. So yes, that is true. It does contain line CD. Then we can look at line L and line CD intersect at point D. So line L is this one going through. That dotted line there means that the line is going through the plane. So it's not in the plane, it's going through it. And then we can see again that it intersects line CD, which is the line we had circled before. Line CD is there, right here. And they do intersect at point D there, right here in purple. So, it is true. Once again. Number 3, we have line CD and C intersect at point D. Now, we can actually tell this without even looking at the image, but because the names are CD and CE, they both include point C. So if we're talking about two different lines and there's a common point, that common point is where they intersect. But we can look here again. Here's CD once again, and CE. And you can see that they intersect at point C, not at point D like it says. So this is our first false question. Number 4, plane M intersects line L at point D. Again, remember I said that line L was going through. That's what the dotted line means. So here's L. Plane M is that big sheet going through there, and L does go through M. And it is at, again, point D, so that is another true. Number 5, plane M contains point F. Point F is down here. Is that in plane M? Definitely not. It's in plane N, as in no. So that one is false. Then we can look at number 6, points M, not points, sorry, that was a typo. I fixed it a couple times, I never saved it. That is plane M and N intersect in line CE. So you can see line CE is right here. You can see the two planes intersect in line AB, not CE, so that one, again, is false. Number 7, points C, H, and D are collinear. So C, H, and D all lie on that line, CD there. So that is true. They are collinear. Points C, E, C, and D, are collinear. E, C, and D. E and C are collinear. Obviously, 2 points are always collinear. C and D are collinear, but the combination of the three are not collinear. They are all in the same plane, but not the same line. So this one is false. Points C, D, and F are coplanar. This one's tricky. I actually had a debate this one with our other teachers. So C, D, and F, you see, are in what appears to be different planes. However, to be coplanar, or to form a plane, you have to have 3 non-collinear points. We have 3 non-collinear points here, so they are coplanar, but you just can't see the plane that they are forming pictured here. but this one is true. It's a tricky one. And then the last one, points C, E, H, and D are coplanar. C, E, H, and D are all in plane M, so because of the image we have, we can say that is true. If we didn't have this picture, we can't say that's true, because we don't know that all 4 points would be coplanar. Here, that is true, based on the image we are given. Okay? So now let's get into these notes. Again, when we did the notes, just like 1-1, we did vocab, so we are going to skip through here, again, those 40 words that we did then. Today we're just going to look at inductive reasoning, conjecture, and a counterexample. So inductive reasoning is reasoning that you use based on patterns, things like that. So we're going to look at a lot of patterns today. And then conjecture is just making a statement based on those patterns. And then a counterexample to show that something, a conjecture is false. Or can be false. It's not always false. So, example 1a, here we have a pattern, and we need to find the next term in the pattern, also make a conjecture based on the pattern. So we're just going to write a sentence that is explaining what's happening with the pattern. So really we need to figure out what the pattern is first, come up with our conjecture, use our conjecture to come up with the next number, okay? So, we'll write our pattern again, 2, 4, 12, 48, and 240. So we have all these connections here. So to get from 2 to 4, we could add 2, right? And then from 4 to 12, we'd add 8. And then from 12 to 48, we're adding 36. There's no real pattern there, right? So let's look again. To get from 2 to 4, we could also multiply by 2. And then 4 to 12, we'd multiply by 3. 12 to 48, we multiply by 4. So 2, 3, 4, 48 times 5 is 240. So that's our pattern. We're multiplying each previous term by the number that it is, or the term number. So here we're multiplying by 2, we multiply the next one by 3, by 4, and then by 5. So obviously our next one we're going to have to multiply by 6, so we'll do that in a minute. But first we're going to write out our conjecture. So our conjecture is that each term, or each next term, is the previous term multiplied by their position number. So for example, the 4 was in the 2 spot, we did 2 times 2 to get there. The 12 was in the 3 spot, so we multiplied 4, the previous term, by 3, and so on. So position number. So again, that means that we're going to take the 240 and multiply it by 6. So 240 times 6, and that comes out to be 1,440, if you haven't figured that out already. And there's our answer. So our conjecture is that each next term is the previous term multiplied by their previous number, and then our next item in the sequence is 1,440. Here's another pattern. So we need to decide what these numbers represent first. So looking at each picture, you see that it's a triangle, right? 3 angles, 3 sides, both of those things, right? So let's look at the angles alone. So if we're looking at angles, if we look at number 9 here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're too many, right? We got 12. So it's not that. So sides, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. It's the number of sides. So that's what we're looking at, these numbers are. So from 3 to 9, from 9 to 18, let's see, 3 plus 6 gets us to 9. 9 plus 9 gets us to 18. Could be that. Let's look at multiplying. 3 times 3 gives us 9. Okay. 9 times 2 gives us 18. So 3, 2, if we go to 1, the next one's going to be 18 again. And then we have to go to 0. That doesn't make any sense. We don't have any sides anymore, right? So it can't be the 3, 2, 1 pattern. So it's got to be the addition. So it's adding 6 here and adding 9 here. So there's actually a second level to this that's increasing by 3, right? So that means our next one we're going to add 12 because 9 plus 3 gets us that 12, right? So now let's write our conjecture before we figure out what our pattern is. So our conjecture is that the number of sides are increasing by 3 plus the last increase. So the number of sides is increasing by 3 plus the last increase. Okay, so now let's draw our picture of this. So we know that basically we're adding a layer, right? So we know we're going to have 4 layers of triangles here. And then I just like to go down to the middle from the top. And then the middle of that triangle. And there's our shape. And 12 plus 18 does come out to be 30. So there's our pattern and our conjecture. Again, guys, remember if you're watching this video, you can pause at any time, rewind it if you want to. If you missed part of the video or you don't understand one, go back and rewatch it. Seeing it multiple times could help you out in the long run. Okay, so our next one here, we need to make a conjecture again about the sum of an odd number and an even number. So we're going to list some examples that support it. So we're actually going to do this a little backwards here. We're going to come up with our examples first, so that way we kind of know what the conjectures are going to look like. So we know that when we add 5 is odd, plus 4 is even, 5 plus 4 is 9. Odd. Now let's say we add 8 plus 11. 8 is even, 11 is odd, 8 plus 11 is 19, which again is odd. So we get odd numbers both times, so that means, as my old physics professor used to say, Dr. Friedman, 2 means true. So that means we got 2 examples here. So that means every time you add an odd and an even, it's going to be an odd. So that's our conjecture. So we just write that out in a sentence. When you add an even to an odd, the sum is an odd number. So we got our conjecture, we got our examples, we can move on. Part B here, again, still looking at conjectures. So now we need to draw a picture of what's going on here so we kind of know what our conjecture is going to look like. So we know that LM, so from point L here to point M down here, it's 20, right? And we know that LN is 14. And then and M is 6. And 6 plus 14 is 20. So there's our picture. That's what it actually is representing. It's a line. Now the question is, could it be a triangle? The answer to that is no. Because there's a law in geometry that we have not learned yet, but we will very soon, that says that the sum of any two sides of a triangle need to add, or the sum, so needs to be greater than the length of the other side. So here we have 14 plus 6, that's equal to 20, not greater than 20. We can't make a triangle then. So if you were to take this bottom line here and pull N up, L and M would then shrink down. They can't stay where they are. So that's where the problem it lies, okay? So our statement here is that N is between L and M on a line. Okay, so our next one here, there's two parts to this. I combine them into one. So it says A, but there's no part B. This is part B. Part A was to make this graph that's already pictured for us. So we don't have to make the graph. But really the graph doesn't help us that much, because if you look at the table, you can see that month 1 is 500, month 2 is 1500, month 3 is 4500. If we take off the zeros, 5 to 15 is 5 times 3, right? 15 to 45 is 15 times 3. So they're just multiplying by 3. So our conjecture here is that the sales are multiplying by 3 each month. So we just take the 4,500 that it was, multiply it times 3, and we get 13,500. There we go. Pretty basic if you just see the pattern. Gotta look for those patterns. Okay, our next one here is actually to find a counterexample. It's our only one that we're going to do like that besides our exit ticket, and we'll talk about that when we get there. So here we have some counties in Texas. We need to decide which ones don't follow this pattern. So it says that the unemployment rate is highest in the cities with the most people. So let's look at the table for the highest rate of unemployment. The highest rate of unemployment should match up with the highest population. Highest rate of unemployment is down here with Maverick County, but the highest population is with El Paso County. There's our, right away, just like that, we find our counterexample. So we just make that into a statement. We can say that Maverick County, I'm going to shorten this up, MavCo, has the highest rate of unemployment, but only the third highest population. There we go. There's our counterexample. Alright, so now on to our exit ticket. After we did some work in class, but we're going to skip over that. So our exit ticket here, again, looking for a counterexample. The statement here is that the greater the population of a state, the lower the number of drivers per 1,000 residents. So we're going to look at the numbers of licensed drivers, look for the lowest. That should also match up with the highest population. California looks like it has the lowest with 627 licensed drivers per 1,000. And it also does have the highest population, so those match. The next, so these are out, we'll mark them out. Texas is the next lowest licensed drivers and has the next highest population, so that's out. Next lowest licensed drivers is Wisconsin at 703, and that is also the next highest population. So then we're at 745, but they do not, West Virginia here does not have the next highest population. Alabama does, so that's a problem. Alabama has the next lowest licensed drivers, but again, not the population. And if we look at Vermont here, they have the highest number of licensed drivers per 1,000 and the lowest population, so that makes sense with it. So West Virginia and Alabama are our counterexample. Alabama, West Virginia. And there we have it, guys. I'm going to go ahead and post these notes, and I will post 2 more tomorrow. I'm going to try to do 2 a day to catch up, and then I'll keep up the rest of the year. That was my plan anyway. We'll see how that goes.